So we're going to pause feature development on our application for just a second because we're going to talk about the life cycle methods of a view controller. So we inherit in our custom view controllers from this class UI view controller. As with many things in developing in the iOS framework, we tend to inherit in our custom classes from some kind of base class because those base classes do a whole lot of work for us. They navigate UI flexibility by knowing when the screen size and orientation changes and laying out the view appropriately for us. And they manage object conservation as well by determining which views need to be on screen when, instantiating only just as many views as are going to be necessary, and ensuring that those views are available when we need them and are not taking up memory when we do not need them. We don't want to have to deal with all that complexity, so iOS deals with it for us. However, we may sometimes want some control over what's happening with our views in our application based on when they're getting set up or maybe when they're getting torn down. For that purpose, iOS provides us with hooks into the view lifecycle, the process of the view getting set up and torn down. And those are called view lifecycle methods. We're going to take a look at some of those today. You can find diagrams on the internet of the way that these view lifecycle methods work, and they have them for Android and iOS. Let's take a look at one for iOS. I'm not a huge fan of using these diagrams to demonstrate lifecycle methods because most of them don't include all of the lifecycle methods. So for example, this one, which is a popular one that you'll see a lot, shows view will appear, view did appear, view will disappear, and view did disappear. And that's valuable, but those are only a subsection of the lifecycle methods that run in iOS. The other reason that I'm not big on using these diagrams to teach this concept is that there's another way to teach this concept that's more interactive, which is that we can go into the code ourselves and we can learn what the lifecycle methods do by running them. I think it's an often overlooked advantage of software engineering that the libraries and languages that we're trying to learn about we can run on our own personal machines. It's not like trying to learn about space or the ocean or the forests where we have to go out and observe something in the wild that we don't have access to or read about it in literature or research studies. We have all of those things for software engineering, but in addition, the system that we're trying to learn about is a system that we can run and that we can modify by ourselves to poke around and find out what's going on. So we're going to do that today with our application. I've made a couple of modifications to our detail view controller to illustrate this concept. So currently, when we open our app and click on one of these cells, we go to this detail view controller. There's not much on it. It's blank, but it's a fully functioning view controller which runs all of the lifecycle methods that any view controller would run. And we can take advantage of that for the purpose of learning. So here's what I've done. Inside of my detail view controller, I have called all of the lifecycle methods, or a large portion of the lifecycle methods. I've overridden these lifecycle methods and printed out their names. So now, anytime these methods run, their names will print in the console. I found these methods by typing in override func view and then allowing XCode's autocomplete to show me the methods that had to do with view setup and teardown. Then I scrolled through the list. Now, when we see a list of methods like this in XCode, XCode helpfully provides us with a description at the very bottom right here of what it is that that method does. For example, view safe area insets did change is called to notify the view controller that the safe area insets of its root view changed. So I can scroll through each of these just like this and find out in general what each of them are doing. So now I have a bunch of those methods overridden in my class. And when we run our application, we'll be able to see the order that they run in. So let's go ahead and rerun our app with these modifications. Okay, let's start our view life cycle. We click on this cell and we see the order in which the methods are run. First, loadView is run. This is an internal method to iOS, and there shouldn't really be many reasons that you would want to put code in here. But that's going to set up your view, and it is called every time the view is accessed on or rather the first time your view is accessed on your view controller. Immediately after load view, we see view did load. This is where you're going to be making the majority of your changes to the view, because once the view has loaded, it is available for you to make your modifications. This is a method that we've used in the past. Then we see view will appear. This runs before the view becomes visible to the user. Then view layout margins will change. This is where iOS is setting up the layout margins for a view to determine how things are going to be arranged. Then we get to view will layout subviews. Now that we know where the margins are, we're determining where each of the pieces of our view are supposed to go. Then view did layout subviews. This runs immediately after those subviews has been laid out. And finally, it's time to make the view visible, which we do by making the view appear, immediately after which we see the method view did appear runs. Let's keep going and see how these methods are run when we navigate back and forth between this view controller and another one. So when I navigate back, you see two methods ran. View will disappear before we navigated back, and view did disappear after we navigated back. Now we're going to go back to that same view controller, and you see load view was run, view did load, view will appear, etc., etc., just like we saw the first time. Let's confirm that if we click on a different cell, the same methods still run. And they do. Now, let's see which of these lifecycle methods run when we change the orientation of our device. Command left arrow changes my simulator, and I see view will layout subviews and view did layout subviews run again. This happens because when we change the orientation, we're able to make changes to the subviews. Say we wanted things to appear next to each other in landscape that appear one on top of the other in portrait orientation. These methods give us a hook in order to make those changes programmatically if we would like to. So if we go back to portrait orientation, we'll see that those methods get run again. When we navigate back, we see that our disappearing gets run, and so on and so forth. So there's one thing to note before I close this out, which is that you'll notice that several of these methods I just printed in. But load view at the top I called the super first. Most of the lifecycle methods are hooks. They don't do anything on iOS's side. iOS just calls them to give us an opportunity to run our code. Load view is different, and this is the reason it's a little dangerous to be messing around with load view. iOS actually uses load view to do things, and so if we don't call the super on these hook methods, it doesn't matter because the super doesn't do anything. However, load view actually does do things, and so we need to make sure we're calling that super or our view breaks when we override.